Hello, everyone. Today, we're going to start studying transformations. This is going to be a set of 4 videos. The first one dealing with vertical transformations, the second one with horizontal transformations, the third one comparing and contrasting vertical and horizontal transformations, and the fourth one, me doing your homework in MyMathLab to show you how to graph when you're answering transformation questions. So let's get started now with vertical transformations. As I am here in front of this gorgeous, gorgeous photo of Oregon. Here's your basic function, f of x equals x squared. It's in black, and there's a picture of it. Notice that I changed the scale in order to make these graphs more visible to you and be able to differentiate them from each other. All right, so here's your basic graph, your basic function. Y equals x squared. There it is up there. And I chose a few points, 0, 0, 1, 1, negative 1, 1. Now, what having a number bigger than 1, 3 is definitely bigger than 1, putting a number greater than 1 in front of my basic function makes me multiply all of the y coordinates of all the points. That means that this 0 will be multiplied by 3. And this 1 will be multiplied by 3. And this 1 will be multiplied by 3. That 3 right there. So that 3 times 0 is still 0. So notice that both graphs share 0, 0 as a point in common. Now, on the other hand, when you multiply 1 by 3, 1 times 3 equals 3, which means this point becomes this point. X is still 1, but y becomes 3. Over here, this 1 is multiplied by 3, and so we get negative 1, 3. This 3, again, multiplies the y coordinates of all the points on the basic function, but not the x coordinates. And so you get a graph here that's higher. Now let's look at one that's kind of less easy to see. Here we have y equals x to the third power, x cubed. Y equals x cubed, or f of x equals x cubed. And here it is in black. And some of those points are 0, 0. Well, yeah, 0, 0. And 1, 1. And negative 1, negative 1. Now we're going to be multiplying all of the y coordinates by 9. This, incidentally, I'm not sure I showed it to you, this is called a vertical stretch. When the a number multiplying the function is a number greater than 1, you get a stretch. So here 0 multiplied by is still 0, so both graphs share the point 0, 0. we're going to come to the point -1 on the basic function. This y coordinate, -1, will be multiplied by 9, and so it becomes -9. So this now is the point -1, -9. Imagine the black graph being pulled at both ends. That's going to make it closer to the y-axis because you're pulling on both ends. Now here we have the basic graph y, or f of x, equals the square root of x. And here it is, and here are some choice points right here. By the way, that blue continues down. It's just that graphing calculators can't show points that come too close to being vertical. Okay, but I'm going to put in those blue points for you. Let's see, there, there, and there. It is continuous. So let's see, both of the graphs share the point 0, 0 for the same reason as before. And then we have 1, 1. I didn't have room for 4, that would have been at 2. All right, so this will be 0.11. Now here we have in front of the basic function 5. It's a number greater than 1. It's going to multiply all of the y coordinates, so 0, 0 remains 0, 0. But 1y will become 1, 5. Let's see, 1, 2, 3, 4, 5. Come straight up, and there we are. There we are at 1, 5. Which is why this part, this stretch is stretched up and it's closer to the y-axis, which is one way you can kind of tell about vertical stretches. They are always or almost always closer to the y-axis. Here they certainly are. Now vertical shrinks. When I was young, we called them vertical contractions, but now we say shrinks. Here's our basic graph, y equals x squared. F of x equals x squared in black. And there you see 3 points on the black graph, 0, 0, which I neglected to write. 0, 0. 1, 1, and -1, 1. Our shrink consists of multiplying the basic graph by a number between 0 and 1, and 0.33 is definitely between 0 and 1. And here I have that written for you up here in English, rather than in math language. In math language, we would be saying that A is strictly between 0 and 1, not equal to 0, not equal to 1. So when I multiply 1 go back to green. Well, let's do 0, 0 first. When I multiply for this graph right here, which is the shrunk graph, zero multiplied by 0.33 is still 0. But 1 multiplied by 0.33 becomes 0.33. Let's label that 0.33. And 1 multiplied by 0.33 becomes 0.33. Except, there it is right there. Eraser, there. I get carried away sometime. We come directly down, right? So we've still got -1 as our x coordinate, but now the y coordinate is 0.33. And so there, this looks wider, and therefore there's a temptation to say, but it hasn't been shrunk, it's been expanded. But no, remember what's being expanded. It's the y coordinates. So think in terms of the graph being lower and closer to the x-axis, which is what happens when you multiply y coordinates by fractions. Numbers between 0 and 1. Let's go over here. Here we have the basic graph, x cubed. And so we have these points, 1, 1, -1, -1, -1 rather. And 1, 1. And 0, 0 on the basic graph. Now, our y coordinates are going to be multiplied by 0.123. I thought that was very creative. 0.123 will multiply all of the y coordinates but leave the x coordinates alone. So our x coordinates are still -1, 0, and +1. But now, 0.123 is a very small number. It's just a little bit above the x-axis here. When you multiply 1 by 0.123, you get 0.123. And when you multiply -1 by 0.123, you get -0.123. Just a little bit below the x-axis, so you can't even really see it. But as we go along, all of these y coordinates drop. Or here, it looks like they're coming up, but they're all being multiplied by 0.123, which places them closer to the x-axis. For instance, this is -2. Well, -2 is not visible, okay? That would be -8, -1, -2, -3, -4, -5, -6, -7, -8. So that would be -2, -8. And then on and on. I mean, you know, on the basic black graph right here. I really tried to not graph because it's never very good. But now negative 8 is being multiplied by 0.123. Now what is 0.123 multiplied by negative 8? Let's find out. There's the calculator. Okay, negative 8 times 0.123 gives us negative 0.984. That's almost, but not quite. Negative 1. Here's negative 1. But a line going straight down from there will put this a little above. And I should make that green. So almost, but not quite negative 1. As a result, this shrunk graph moves closer to the x-axis. It's not a matter of above or below, it's actually a matter of closer to the x-axis. Because the y's control how far a graph is above or below the x-axis. Excuse me. Now over here, we have the square root of x with points 0, 0 and 1, 1. But we're going to multiply 1, 1, 1. We're going to multiply this one by 0.43. Well, 1 times 0.43 is 0.43. So this point now becomes 1.43, while 0, 0 remains 0, 0. So our shrunk graph, I had to go in and try to make this look dashed. Because see how that is? What I discovered was when you make a graph vertical, it's easy to turn it into just points. But when it's horizontal, it is not easy at all because all of those y coordinates are being crammed in. It looks solid. It's very irritating, but educational. All right. Now we're going to do a reflection across the x-axis. In other words, turning upside down. How do you do that? Well, you take a basic function and you put a negative sign in front. Remember that negative sign is really a negative 1. Negative 1 will be multiplying all the y coordinates, leaving the x coordinates alone. So 0, 0 is going to stay 0, 0 because 0 times negative 1 will remain 0, 0. When you multiply this 0 by negative 1, you still get 0. On the other hand, this positive 1, when it gets multiplied by negative 1, becomes negative 1. And this positive 1, when it's multiplied by negative 1, becomes negative 1. As a result, your reflected graph is an upside down version of the basic graph right here. As always, leave it to x cubed to be a little different. So for the moment, I'm going to say, yes, this is the basic graph f of x or y equals x to the third. And there it goes. And we have points, let's see, 1, 1. And I believe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I am really happy. I am really happy because now I have room. Here's 1, 1. And here 2 to the third power is 8. So I have 2, 8. I have a bunch of points to play with. All right, here's 1, negative 1. 1, negative 1. And here's 2, negative 2. Negative 2 cubed is negative 8. Okay. There. And there. And there. And there. So this is the point negative 2, negative 8 on the basic graph. Now we're going to reflect the basic graph f of x equals x to the third by putting a negative sign, which is negative 1, in front of it. Negative 1, positive 1 multiplied by negative 1 goes here because the x coordinate stays the same. Positive 8 will go down to negative 8. And over here, over here, 1, negative 1, that's a negative, negative 1, negative 1. Well, x will stay negative 1, but now negative 1 multiplied by negative 1 is positive 1. And down here, negative 2, negative 8, when it's multiplied, when it's hit with a negative sign or a negative 1, will become a positive 8. X is still negative 2, but y becomes positive 8. So this is negative 2, positive 8. And this is negative 1, 1. So now our blue graph also goes through, 0, 0, of course, regardless of what you multiply 0 by, except 0, you're going to get 0. So 0 times 1 is 0. So both of these graphs cross at 0, 0, because they both contain 0, 0. As a result, your reflection, this goes down here, and this goes up here. Both sides are reflected across the x-axis. So in this case, we can't really say it's upside down, or we could, depending on how you look at it. All right, I'm looking for, there it is. Here we have f of x equals the square root of x right here. Now, if I did what I should have done, let's see, x equals 1, x equals 2, x equals 3, x equals 4, Yahoo! Here's 0, 0. Here's 1, 1. And here is 4, 2. There's 2 right there, 2, 1. All right, now we're going to reflect the basic graph across the x-axis. 0 multiplied by -1 is still 0. But this 1 multiplied by -1 gives us 1, -1, 1, -1. And for -2, the -2 hit by a -1 will flop down here and become the point for -2. And so here we have our vertical stretch, vertical shrink, and reflection across the x-axis. Now, what about just shifting the graph directly up and directly down? We're going to do that also right now. A vertical shift up means this. You take your basic graph, and if you shift it up 3 units, then all of the y coordinates are going in the basic graph are going to have 3 added to them. Let's take a look. Make it a little bigger. That +3 adds all the y coordinates, adds to all the y coordinates, but leaves the x's where they are. That's true for all vertical transformations. The x's are left in place. It's the y's that change. So here we have the basic graph, y equals x squared. Here we have the transformed graph, which is shifted up 3 units. The x's all stay the same, the x coordinates, but the y's are going to change. Here we have 0, 0, but if you add 3 to 0, you get 3. Here's 1, 1. If you add 3 to this one, you'll get the point 1, 4. And with the point 2, 4, if you add 3 to 4, you get 7. So this is the point 2, 7. 2, 4 to 2, 7. Here's my cat who wants to get in my lap. Come on, you can't stay up here. Come on. Okay. Loud purr. Mwah. Okay, point -1, 1. Well, we're going to add 3 to that one, and we get 4. So -1, 4. -2, 4. The only thing affected is the y coordinate. I'll add 3 to 4. That gives me 7. So this is point -2, 7. And that continues. 7 plus 3, well, never mind. Okay, oh. Now here's y equals x to the third, y equals x cubed, basic graph. We're going to be doing the same thing, and look, this time it really is just picked up. It's physically moved up. F of x equals x to the third is the black graph, and all that's happened is the graph has been physically brought directly up 4 units. All the x's have stayed the same, only the y coordinates have been moved, well, have had 4 added to them. I'll get English someday. So here's 0, 0. When 3 is added to this 0, we go up to, oh, it's 4 we're adding. I've got this thing for 3's. When 4 is added to this 0, we go up to 1, 2, 3, 4, right here. Here we have 1, 1. When 4 is added to 1, we go up to 4, 5, 2, 5. This is 2, 1. No, this is 1, 1. I'll get it. This is 1, 1. When we add 4 to 1, we get a 5. So now, this point is 1, 5. Now down here, we have -1, -1 on the basic graph. When I add 4 to this -1, I'll even write a +4. -1 plus 4 is +3. So we're going to move directly up to the point -1, +3. And let's see. 2 cubed is -8. 1, 2, 3, 4, 5, 6, 7. -8 right here. -8. So 2, -8 is on the graph of f of x equals x cubed. But now look, this transformation, -2, -8, this transformation is going to add 4 to all the y coordinates. So -8 plus 4 is -4. So this should go up directly up to -1, -2, -3, -4. How about that? Okay, I've offended my cat. I'll be in the doghouse for a while. Or the cat house. No, doghouse. All right, is this cool or is this cool? I am constantly amazed at the patterns in mathematics, that they're so regular. I mean, who made the decision that we're going to live in a universe? I mean, we do have chaos, but even that is pretty darn regular when you look into it. I am amazed, totally amazed. This stuff amazes me. Well, I can be amazed, but let's do math. Here's the point 0, 0. Here's the point 1, 1. And hopefully 1, 2, 3, 4. Yes, indeed. Here's the point 4, 2. Now these are going to be shifted up by adding 5 to all the y coordinates. So 1 plus 5 is 6. Come directly up. Is that 6? Yes, it is, because that's 5. 0 plus 5 is 5. That 1 plus 5 is 6. So now this is the point 0, 5. And this is the point 1, 6. And this is the point, if we add 5 to 2, we should get 7. So this is 5, this is 6, this is 7. Ooh, yes, indeed. This is the point 4, 7. So what this does, plus a number, plus a positive number, moves the graph, physically takes it and moves it up. Doesn't change its shape, doesn't stretch it, doesn't shrink it, doesn't turn it upside down. It just physically moves the same graph up a certain number of places. Well, where there's an up, there should be a down. Right here. We're going to take the basic graph and subtract 3 or add -3. They're the same thing. But just for the sake of being easy, I'll say subtract 3. We're going to subtract 3 from every y coordinate on the graph of f of x equals x squared. We're going to subtract 3 from 9. And so here at 3, right down there, this is 3, 6. Was 3, 9, but we subtracted 3. 4 minus 3 is 1. So we now have the point 1, 1. This is the point 0, 0, 0. When we subtract 3 from the y coordinate 0, we get, someone just stepped on my new phone, the point 0, -3. She's washing the paw that made the phone go ding. All right, and so on and so forth. 1 minus 3 is -2. So here's the point 1, -2. And 4 minus 3 is 1. So here's the point 2, -1. And 9 minus 3 is 6, so this is the point -3, 6. So this graph, the basic graph, has been dropped 3 units, and it's still the same shape. We're just seeing more of it because it's dropped down. Same thing for x to the third minus 4. All of these y coordinates have had 4 subtracted from them. And f of x equals the square root of x. All the y coordinates have had 5 subtracted from them, which has physically moved the graph down. And that's the only change. So now for a recap. Vertical stretches, when you multiply the basic function by a number bigger than 1. Vertical shrinks, when you multiply the basic graph, or the basic function, by a number between 0 and 1. In other words, a fraction. No, but I guess it's more proper to say a number between 0 and 1. All right, here you get a vertical reflection, a reflection across the x-axis, when you multiply the basic function by -1 or just a negative sign. They all turn upside down, except what's called an odd function. There, the part below the x-axis moves above the x-axis, and the part above the x-axis moves below the x-axis. Or, the part above the x-axis moves down, the part below the x-axis moves up, because odd functions are like that. We haven't learned about that yet, but you're seeing the result. And here we go again. This time, the square root of x has just been moved upside down. As long as you just have a negative sign, there is no change in the shape. You're not stretching it, you're not shrinking it, you're just turning it upside down. Unless you've got an odd function. Okay, now, you can vertically shift a graph up just by adding a positive number to all of the y coordinates on the basic graph. And you can physically move a graph down, the basic graph down, when you subtract a number greater than 0, or you add a negative number. Either way, you get -3, or -4, or -5. So let's just say subtract a positive number from the y coordinates. That physically moves your graph down. And that's it for vertical transformations. The next video is horizontal transformations. See you later.